So welcome, everyone. Welcome to the first annual AnacondaCON. And I want to thank you so much for joining us. As Dwayne said, we put a lot of effort to put all this together, but it wouldn't be anything without all of you. So thank you so much for joining us. I'm really glad you came, despite the terrible Austin weather that you have to endure. And also, this is the only first AnacondaCON, right? So, of course, next year's will be the only second AnacondaCON, but we'll ignore that for a second. But this really is a major milestone for us as a company. And it's really nice to be, as I look around, I see familiar faces, I see people I've worked with, I see lots of people that I'm looking forward to meeting. And so I'm really glad you guys could join us. And one of the things that when we were first talking about putting this together, one of the things we talked about was, does the world really need another data science conference? And so we were really looking to say, what can we do that's a little bit different? What's really relatively unique about our community? And the vision that we came to was to not dwell on a single technology stack or a single language, perhaps, but to focus on something that, that actually reflects the eclectic and diverse nature of this ecosystem, of the people in it, all the ways that people are using data science and predictive analytics. And we're very, very well, here at Continuum, and certainly as the makers of Anaconda and many of the libraries that are used within it, we're very aware of that, just how diverse that ecosystem is, how fast it's innovating, because Anaconda is the leading open data science platform. So one of the things that, that many people may not be aware of is just how popular it is. By the end of last year, we had over 11 million downloads of Anaconda, and the slide's not a typo, because now by February, 6th, 7th, we're up to 13 million downloads. To give you a sense of the rate of growth there. And Conda has served up 25 million package installs each month. Now, those are pretty impressive numbers, right? By any metric, I think those are pretty impressive numbers. But on a day like this, I think it's really important for us to take a step back and look at how we got here, where we came from. So if we look at the world 5 years ago, which is how old Continuum is, we founded this company right at the time of what you could call peak Hadoop, right? Where the second derivative, perhaps, maximized. And so at the first PyData event that we did in March of 2012, we organized that. Travis had a nice little talk. He summarized some of the things he saw at the Strata Hadoop World conference that he was just at. I think at the time it was still called Strata. It wasn't quite called Hadoop World yet. But he gave this talk at Google that highlighted the technical landscape as we saw it there. And certainly Hadoop was taking over in the data storage space. Everyone was going gaga over MapReduce, people trying to figure out how to do MapReduce with MPI, I guess. And one of the things that people also that we got was a sense of like, oh, there's some R and there's some Python. We have no idea how to deploy that in a Java or a .NET-based infrastructure, right? So that was something that we saw a lot of. Prior to this, we'd done a lot of work in Wall Street and scientific and engineering places that had a lot of traditional C, C++ code. They had infrastructure, they knew how to kind of handle some of the stuff. But for the data science people, for the IT and the software development lifecycle, all these other people, there was not really a good idea there of how to deploy these data science things. And we had a lot of discussion there. I injected the idea in Travis's head of using this picture from The Little Prince about a snake swallowing an elephant. But actually, one of the things that was really important, and something that hasn't changed, part of the vision, is this idea about bringing code to data. We looked at what would happen to us if we did nothing about the situation. There was a very strong probability that we'd end up rewriting a BLAS or something in JavaScript. But actually this idea of moving code to data is something that stayed the same throughout this entire time. There's one sort of this one thing that's not changed, despite all things that have changed in this time. It's that in the world of the future, actually the world that we live in today, I guess, we will be moving code to data. There's just no question. We'll be moving code to data, full stop. Now the question, of course, that raises, what language is that code in? Now at the time, our answer was Python as much as possible. And that was because we liked it. It's a very enjoyable language to use. But the world's a very diverse place, very heterogeneous place. And it's not the only language. There's other languages and other technologies. But Python for us was important because none of us were forced to use Python. We all came to it and stuck with it, not only because the language is awesome, but also the people that we got to be around. And that little thread led us to thinking about, or to understanding, moving code to data, okay, that's all great, but But that code that you move to data, not only what language is it written in, but who writes it? Who writes that code? And Python, one of the things that's very important about Python is that its accessibility means that lots of people who understand domain problems, people who do not have degrees in computer science, can actually be asking questions, contributing their ideas, modeling the processes in their head, and giving that to the computer in a way that can run efficiently and run at scale. There's a really, really great quote that I found. This is from Paul Hennekamp, who is a FreeBSD developer. And he has this amazing, really beautiful quote that I think really deeply resonates with Travis and myself. We want to build better tools. And I think hopefully the last 5 years have borne out that our vision and our technical guidance and leadership, we have actually managed to deliver some really amazing software to the world and are continuing to deliver it. And there are new things that are yet to be built that we will pursue in very much the same kind of way. And I think this little chart shows just how much. Some of these projects are actually quite young, quite new. And we've launched some of these really cool projects. Most of them are in Python. Some of them support R and Scala as well. We've taken actually a much more inclusive view towards languages. But we absolutely focused on technical innovation in a few key areas. This looks like from the beginning, in 2012, people were like, oh, you guys are insane. 6 startups in one, and you're doing a compiler and some web viz, and there's packaging stuff. Why don't you just use Yum? There's all of these things going on. But we stuck with it because we had a technical vision that we wanted to empower more people to connect to more data. We wanted to have more people being able to ask better questions of data. One of the things that actually I saw a long time ago that really stuck with me is this idea of access to tools. And the Whole Earth Catalog, I think, was also one of Steve Jobs' favorite little things. And this is beautiful because there's just one little subtitle there, right? The Whole Earth Catalog, access to tools. We are entering, we may already be in, the new era of data, and that absolutely requires a new kind of literacy. Not just point and click, not just make me a big red solve button, but actually understanding how to communicate to the computer, having the computer understanding what is the human intended to communicate. We have more and more people in the world that are able to develop software, more and more people that find, you know what, I can download Python, I can learn it in a weekend, I can download some C++, I can download some Ruby. It's not rocket science. We can do these things. All I need is an internet connection. So the actual process of software development is commoditizing out, and there's many disruptive things that are happening actually that sort of continue to push that commoditization. But one of the things that we saw was that there will absolutely be, in the era of data, there will be new kinds of services and business models that emerge in a data-rich world. And so we wanted to give access to tools to everyone to build that. But a really, really important thing is that we really, really wanted that to be global. We wanted to be accessible. We did not want it locked up in ivory towers. So people ask sometimes, well, what is Anaconda? I get this from the guy at the gas station a lot. And I answer, well, it's the leading open data science platform. But what I really want to tell him is we are building a whole Earth catalog for the data era. And that leads to then, of course, a sort of a very, very interesting concept that dovetails with that. Okay, well, you guys seem to build a lot of software, and most importantly, you guys seem to build a lot of open source software. Why, if you're doing all this great stuff, are you giving it away for free? And I have a lot of people I talked about open source. And I think one of the unfortunate things that happens with open source is that people think it's about licenses. If it's a GPL, AGPL, LGPL, if it's a BSD at MIT, if it's a APL and all these other things, then it's open source. And technically that is true. But that's not really enough, I think, because open source is not actually about licensing models. It's about empowering people. And in an era of software development, when the licenses were open, it meant that anyone could innovate. People were free to innovate. They could get together as communities and talk about the code and fix things and improve things and build new things. So that empowerment and innovation is something that's actually the heart of open source. People sort of I think they pay lip service to it, but it's actually more important than the licenses. There's lots of software out there with one of these licenses that does not have this innovation model built in, does not have this community orientation built in. And what we found as an open source company is that by taking these underlying innovations and making them open source, it fundamentally aligns us with our users, with our customers, and with all of the people in the world that want to innovate on this stuff. It just aligns us completely. There is no divergence built in and baked into the fundamentals of the interaction. And this one of the things that people say about software is that it's eating the world. And what they mean by that is that there is no activity in the world, no infrastructure, no significant business activity that will not be or has not been disrupted by software. Software is eating the world. All the value then accrues to the software and the software makers. And so I think that open source is a mechanism for empowering people and communities in an era when software is eating the world. But open source is not magic. There's no pixie dust there that makes things automatically better because everyone can see all of your bugs as opposed to being able to hide all your bugs. It's not handed down on clay tablets or anything. I think that the open source model, open source itself is one instance of a general class of things that are in the democratic sense of empowerment of human intellectual potential. And also, the reason for that is because in the era of software eating the world, there's a lot of value to closing source that software, to locking people into it. But that lock-in leads to stagnation. And what open source does is it leads to distributed innovation. It gives rise, I think, to a certain level of collective intelligence. And you can see that if any of you are involved. How many people here are involved in open source development in some way, shape, or form? Hands up. How many people have submitted a bug to an open source tracker? More hands. All of you are involved. By submitting a bug, commenting an issue, you are involved in open source development. Your information and your insight and your perspective is absolutely fundamental to what makes open source work. So then the question is, okay, well, what comes next? If software eats the world, what eats software, right? Is it a lot of little fishes and all these like open source hackers and the yellow ones, maybe Richard Stallman, and all of them getting together to like eat this big, well, we won't put any names or labels on that big fish, but is that what really comes next, right? Does something eat software? And I think it's important to think about the fact that software yields data, right? And of course, software also consumes data, which is a little icky, but as software companies were busy eating the world, they left all of this data behind. And you probably even heard the term data exhaust, right? There's just this data wake, data exhaust. And that's what brings us to today. We're on the cusp of an era of data because all these software giants these dinosaurs went and ate all this stuff and they left a lot of data. And in that data arises huge amounts of interesting and fertile, wow, this metaphor just keeps rolling. There's a lot of interesting things you can do there. But here's the question. In that era of data, how do we manifest those same principles of democratic empowerment, right? Of distributed innovation, inclusion, all of these things. How do we bring that to the new world? And that really is the kinds of questions that we grappled with when we started the company. We looked at how we build product, how to build a sustainable company. We did some consulting and training to really bootstrap things. But the questions that we asked from the very beginning were very, very deep. And during quiet, stable times, you don't have to think very hard. You don't have to ask deep questions. But right now, and during times of great instability, great disruption, you actually have to ask really deep questions to get some sense of what the right thing to do is. It's a very noisy environment. I don't think anyone would disagree with the assessment that we're in a time of great technology disruption, hopefully, right? Because we have computation moving to the cloud, we have new kinds of memory class storage coming out, there's GPUs, there's Hadoop disrupting traditional data warehouses, unlocking untold petabytes of historical human activity for richer analysis. And so there's so many different questions, right? If all the computation is moving to the cloud, well, what does that mean for the line between hardware manufacturers and data center operators? Or if you're part of the API economy and you think what you're going to sell as a company is access to an API, doesn't that mean that your competitors are just a few backspaces away from switching? And doesn't it mean that the cloud vendor that you're sitting on is watching every single flop that goes through your software? Right? There's all these interesting and difficult questions that arise, and there's disruption at every level of the stack, from the hardware level all the way up to the software, even to the algorithmic level. What we figured out was that one thing that could align us, one shiny North Star for us in this time of disruption, was this idea of data-centric computing. And this is something that Travis has believed in for quite a long time, something that I sort of had suspicions of, and then as I really started digging into distributed computing and vectorized computation, I realized, oh wow, this is actually the heart of it. And Jim Gray said this incredibly beautiful thing, which I don't know how many people here self-identify as software developers. It's okay, you can raise your hand. No one's gonna throw eggs at you. I'm a software developer too. I used to be before I got into management, but he says this thing that I don't really feel like I learned in all of my years hacking and coding and being on IRC and stuff. This idea that actually it is not written anywhere that data must be separate from code. By separating data from code, we allow the code to iterate. We can box it up. lock it down, sell it, reuse it, and all that stuff is great, but there is nothing that says that there has to be this hard separation between data and code. And in fact, we moved so much in the software economy and the PC era and a certain level of monoculture at the API and OS level, we've moved so much towards the software side that we left all of this data on the table and now, or on the floor, and now as people understand, oh, we need to do a lot more interesting things with data, data gravity is pulling all of this attention back. And Jim Gray made this observation over 10 years ago in a paper. This comment, this concept, is actually at the very heart of the tension between legacy software, legacy languages, computing architectures, and kind of what the world, what we think at least the world needs for the future, data-centric computing. So we recognize the core truth in the statement. That's why we realized that we have to promote and defend open foundations for innovation in this area. Because this is a ripe, fertile new ground. If we didn't get in there and lay down some groundwork, people are going to come in again and lock it down, and we're going to have the same kind of proprietary, locked-in, sort of stagnant technology silos that we have now, actually, in a lot of data systems. So that's what open data science means for us. It's data-centric computing, open foundations for data-centric computing, open foundations for data-centric computing for the purposes of sustaining innovation and harnessing a global distributed intelligence. Now, for our users, it probably means something a little more concrete, right? What we hope people are finding or are getting to is that by using a lot of the tools in the open data science ecosystem, you have frictionless data analysis. When we were talking to some analyst firm at some point, and they were like, well, does it do this? Does it do that? Can I connect to this database? Can it connect to that? And it was weird for me because it's like, well, the answer is yes. The whole column, just like yes, right? Because of course it would. Why wouldn't it? That kind of frictionless data analysis, being able to move from here to there, take this model, apply it over there, run it over there, there's an agility, there's an empowerment that comes with that. And I hope all of you feel that. If not, I would encourage you to then go to a proprietary ecosystem, not use any open source tools, to feel what it feels like when it goes away, right? Oxygen is not really, you don't really sense it until it goes away, and then you're like, oh, that's what that was. But for also, our users, they are in organizations. Almost always they're working with people. We say data science is a team sport, and we strongly believe that. For their organizations, what open data science means is that all of these things that organizations and corporations care about so much when it comes to data modeling, when it comes to statistical prediction and all these things, all of those things are actually much better and much easier with open data science. You get it in a much more legit form, for lack of a better word. But most importantly, when teams are using open data science tools, they are actually much more agile. They can ask better questions, and they get to better insight as a result of it faster. But at the end of the day, the one takeaway here is that open data science gives you the freedom to innovate. It gives you the freedom to innovate. It gives you the audacity, without getting a little too poetic here, but it gives you the audacity to dream, right? You can make things simpler and be more powerful at the same time. You can write a few lines of Python code, decorate it with a number decorator, and be much faster than actually spending a bunch of time, weeks and weeks, hacking out some C++. So what we've seen, and this is something else that Travis and I have a shared experience before we started the company, was that within a lot of organizations, there's so much effort expended and wasted using complexity to counter and fight other complexity. It's like a Band-Aid that's got glass shards embedded in it. It's not really helping you as you layer on more of these Band-Aids. And what we found is that if you can put these computational tools directly in front of those who understand the mathematics and the business problems, actually, we're solving then for insight, first and foremost, and then we'll figure out the scale and the distribution. As long as we're not locked out of those things, we can get to those things, but we're solving for insight. And part of it is that actually what you find out, if you orient that way, orient towards data, orient towards the people who understand the domain problems, you actually dramatically reduce the IT footprint. You dramatically reduce the complexity of the IT infrastructure that's needed. So again, all of this is to say that when we started, and the intuitions we had when we started around data-centric computing, around moving code to data, it's actually been really borne out by the way we've seen the landscape evolve, right? But it's nuanced. It's not just moving any code to data, it's moving the right code to data, moving curiosity of the right people to data. So a quote that I've always loved by Victor Hugo is this one, this idea that there are ideas whose time have come. And I think this is one of those, data-centric computing and putting what we used to call computational scientists, you could call them quants, call them computational biologists, whatever you want to call them, data scientists, they're people who actually understand the problem to be solved, and they use computers to solve those problems. So we don't put the cart before the horse in this case. So, of course, Victor Hugo here was writing not about data science, but really about, I believe, the French Revolution. But we are in the midst of a data revolution. I've maintained that for quite a few years. I'll keep maintaining it until one day it's true, and then I will seem like a genius. But no, I think everyone recognizes, especially with the quantified self and the Fitbits and the Apple Watches, and then the self-driving cars with 360 video cameras on all the time, drones and IoT and all these various things. There's a lot of data coming, and it comes down faster and faster. And we have not made equal strides, not just we at Continuum, but as a culture of technology, as a civilization, we've not really made equivalent strides in managing and harnessing insight out of that data. But we're making good progress now. So the question is, if we are successful, let's say, in establishing data-centric computing, if we're successful in all this, what does that really hold, right? What does the future hold for us? And I want to sort of go in a direction which I don't see a lot of people talking about when it comes to data science. This is Toni Morrison, and she has this really interesting comment that all good art is political. And even the ones that try to not be political, they're sustaining the status quo, so they're political in that sense. It is my view that data science is a process, and it's a process that produces or reinforces or rejects some narrative. So good data science is inherently political by definition because good data science has some kind of impact on the world. That impact, we know that impact pumps oil through pipelines, it pumps money through exchanges, it pumps video and ads 60 frames a second into people's eyeballs. That impact reassembles DNA, it measures snow melt, it optimizes this and that, and it sort of does everything. Data science in every aspect of human activity is fundamentally political in a sense because it has an impact on the world. And it has the ability to generate new narratives about that impact. It can tell a company that what it's doing is not good for its users. It can tell an organization that it has opportunities to go and help its users. All good data science is political. But I want to be absolutely clear from the get-go about why Continuum is here, and that is that we believe if we have more people asking more questions of more data, it will, at a macroscopic level, lead to a better world. Some people use that data and those insights to take advantage of others. Some people use it to better the world. And we believe that on net, the arc of history does bend towards justice if we apply data science thoughtfully towards it. If we don't pretend, as many technologists like to pretend, that technology is value neutral. It's not value neutral, and certainly data science is not value neutral. That power, however, to craft narrative, to reject narrative, to understand how the world is really working, that power cannot be and should not be locked up in proprietary systems or in ivory towers. As the world becomes more data rich, the potential innovations that we can unlock are just extraordinary. If we allow these kinds of walled gardens, these very, very expensive silos to continue to be the mechanism by which we understand the world, the level of rent they can charge is extraordinary. And the downside loss to humanity from the lost innovation, from the lost everything, that downside cost is extremely large. So with Anaconda and with the Anaconda platform, we talk about giving data scientists superpowers. And we really believe that. We're always looking for better ways to give data scientists superpowers. But we recognize that the powers we give, ultimately, they're a component of what makes an entire data science team successful, right? So we, sometimes I've talked to people and I told them, look, you can think of us as basically steel makers. We make the steel, and then we give to people that steel, and then the people in the companies, they use in all manner of activity. But we also know that data is the new oil. And every human activity, every human being, in every waking or sleeping moment is a reservoir of latent information that can be analyzed, that can be captured, that can be modeled, that can be predicted. And I know that our tools, I know that our steel is used in the production, the refinement, and the processing of that oil. And it's all up to you. We do not bias anything in those tools. We do not impart any values in those tools, but it's up to you to use those drills, to use those refineries, to use those pipelines in a way that is beneficial to humanity, to mankind. It's up to you to decide what to do with all that latent information. Right? We take no position on it. We're making the steel. But we know that the steel can do a lot of incredible things. So one of the things that, and I was not, when I first started writing this talk, I was not intending to get sort of very broad spectrum, kind of political with all this stuff, but it's something that I see a disturbing lack of discussion around, and I want to make sure that here at a conference like this, when there is a community of people, that we're talking about this, right? All good data science is political. But data science and good science in general, all science, really good science, it has the potential to make the net wealth and net prosperity and the net capability of human beings grow over time. It's just fundamentally true. It's what we've seen. So the problem is the balance of power in a political system is almost always zero-sum. So if there is not a single use of data that is not somehow political, we have to understand as data scientists, as a community of tool makers and tool users, we have to understand what the dynamic there is. And I think that politics, at the end of the day, where it gets nasty and unfortunate, is when it divides people. Right? People love to come together. People want to be part of a community, part of a tribe. But politicians know, and this is from a feudal lord to modern senators and other folks, they know that by dividing people, they create a tension, and in that tension, they can derive power. And that's unfortunate. As data scientists, and as data-oriented people, we are going to be at the center of how to generate that power or how to heal those divides. And I think it is very important for us to have an event like AnacondaCON where we bring the community of data scientists together to all talk to each other about these kinds of things. For those of you who've been with us since the very beginning, I want to thank you from the very bottom of my heart. There are people here that have been following us and tracking our technology and talking to me and Travis and others since the very beginning. We really, really believe in community. And those people have been part of the community from the very beginning. So I want to thank all of you who made the trip and came down here. Now, the ones who are new, all right, I want to welcome all of you, and I hope that you enjoyed the ride, because the next few years are going to be amazing, not only for us, but in the world. There's so much happening. There's so much really cool stuff to do. But we need, here at Continuum, we need all of your input. We need all of your ideas. We want you to participate in our community, and we need it for us to succeed, because as I said earlier, we want to build an open foundation. We want to build open data science as a community of innovation. And you can't have that. Just like you can't have a conference without people, you cannot have a community without people. If it's just technology, if it's just some repo on GitHub, it doesn't do anybody any good at all. So one of the things that is really important, and the reason I bring that up, is that we are a different kind of open source company. We're a different kind of company, actually. We do consulting, we do training, we do a lot of product development, we do open source innovation. We go and we submit grants and proposals to the National Science Foundation and DARPA and NASA and all these people. We do a lot of things that a traditional startup doesn't really do, because we're guided by those visions. We're guided by that particular principle that we want open innovation, open foundations for innovation. You know, Warren Buffett, who I respect tremendously, he made a comment about the companies he invests in. He looks for companies that have big moats, right? And Silicon Valley, of course, just love this. They just like ate this up. Every blog post, how to build a moat, how to defend your moat, extending the moat. Well, I guess you can't really monetize a moat, because what grows in a moat? Nothing, right? Nothing grows in a moat. There's some fish, but nothing grows in a moat, right? You got your castle, your walls, and you got people in there. Well, here's an interesting question. What grows in a castle? Not much. The castle relies on the villagers and the farmers and all the people in the surrounding landscape to bring in all of the food, all the products, all of the things that the castle itself internally uses. So even as a metaphor, there's a kind of a darkness built into it, even as a very simple metaphor, which I don't think Warren Buffett really probably overthought this as much as I have. But you know, that's a really interesting thing though, right? Next time somebody says to you moat, you're like, well, okay, who's going to pay you tribute? Who's bringing in the food, right? Because that's what keeps the castle alive. You know, am I bringing in the food? What I want you to think about us is that we are not a castle. We have no interest in building moats. We are actually more of a village, all right? Maybe you can think of Continuum as the bustling town square in this large village, and the village is getting bigger and bigger. And that village is actually global. It's a global village of innovation. We have people contributing to open source libraries from all over the world. We have people giving talks, building wonderful notebooks, showcasing all sorts of technology from all over the world. It's a global village of innovation. Lots of people, lots of languages, lots of perspectives, and that's what makes it powerful. So Anaconda is the software, it is the platform, it is the community that you will find here in this village. So You can sort of think of AnacondaCON as our like annual festival, like jugglers and other things. Actually, we have a mariachi band, I believe, tonight. So the metaphor works on many levels here. But that's how I want people to think about us as a company. And the thing I want you to think about yourselves as you hear the conference, and even after you leave. There's a quote that I really, really love. You can see I sort of spend a lot of time looking at quotes, maybe. But this really smart person remarked, the flow of energy through a system acts to organize the system in a natural sense in the natural world, whether it's your body, flowing oxygen, flowing fluids and sugars, whether it's the world at large, whether it's a river flowing through down to the sea. The flow of energy through a system organizes the system. So, we like to joke about, big data and artificial intelligence being overhyped, and everyone hates that term now, and you can't use it on the slide. I didn't use it on the slide. But without getting too grandiose about it, I think we also here recognize with the era of big data, with all of these new techniques for reinforcement learning and all these things, we really are at the cusp of a phase change in humanity and civilization, right? If we make it the next 50 years, we're going to be great. But there's lots of things that could push us apart as well. So I want to leave you with this quote, and I want for you to think of yourselves as both the energy and the system. Your ideas can program cells. Your ideas can explore distant galaxies, right? These are the things that we do here with the software in Anaconda and in this ecosystem. The ideas can carve rocks, it can move mountains. Your ideas, though, can also move each other. So I would encourage you here at AnacondaCON to connect with new ideas, connect with new tools, but most importantly, connect with each other. Thank you very much.